What's going on, YouTube? Otis here, back from my garage to you. I am currently doing a video recording for my Cal 2 class. So, hello, Professor. I've already recorded my all three parts. So, what I'm supposed to do for all the big corners out there, I'm supposed to, we have a final review, take 3 of those questions, and then write them out or solve them on a board and then turn it in for an exam grade. So I've already did all 3 of them, but then I noticed that on one of them when I'm editing the videos, that I kind of messed up somewhere. And I'll show you where I messed up at. But I still got the right answer, but I didn't explain it correctly. So I still have the other 2 parts. So if you see me in a different shirt, it's because I recorded those this morning when I was sleepy. And then now I'm recording this. So I'm not even sure. I hope I complete those others properly as well. So I'm always critical when making videos. So anyways, it's all the big corners. You can stay to watch this or, don't unsubscribe. But I'm showing this for my Cal 2 class, so one day I can become an engineer. So here we go. Number 9 on the final exam, we have f of x equals 1 over cosine. So we did this in class, but I left some room to show that I know how to do it. So we use the Maclaurin series to cover cosine of x, and we have that on the back of our review, and that is, that's Maclaurin series, and then it's all over 1. So this is 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial. So we divide that into 1. So what can we get? This is the first one. How do we get this 1? By dividing it into 1, of course. So we have the 1. We start off 1, multiply 1 by 1. You get 1. 1 into negative x squared over 2 factorial. Then pretty much we just broke it down here. I'm not gonna waste too much time. But what I didn't do on my last one is that here I did this portion. Change this sign. This was add, subtraction. And this is. I didn't bring this down, so I just started to working from here. So I brought this. So you bring this down, and then now, what do you get to multiply to get this itself? So it'll be a positive x squared over 2 factorial. So this is the part where I stopped at, where I messed up. So boom. 2 factorial multiplied by 1 gives you x squared 2 factorial, and then multiplied by a negative x squared, you get a negative x to the 4th. I'm sure you can see this, x to the 4th, and then 2 factorial times 2 factorial is going to be 2 factorial times 2 factorial, so all this is going to be a positive, this is going to be a negative, and this is going to be a positive. And brought this down, multiplied this by this, and that is a positive. And then multiplied it by this negative, which is going to be negative. We're doing long division. So this is going to be negative, and then this is positive. So this is the portion where I messed up, but even though I got the right answer, I didn't put this portion right here, which is because I knew the answer, of course. So we're going to do some scratch work. So we have a negative. Let's see if I can hold this up. We have a negative x to the 4th over 4 factorial, which is what we have here. We're just doing some scratch work to the side. And then we have a positive x to the 4th over 2 factorial times 2 factorial. So what we know with factorials, when you multiply them together, you have to multiply the whole series. So 2 factorial times 2 factorial is going to be 4 factorial. And then what is the difference between the 4 factorial is going to be the 4. So we already know that we have the 4 in the 4 factorial. We just need the things beneath it. So to explain this, we have 4 times 3 times 2 times 1, and we have the 4 over here, and we're missing this portion. So 3 times 2 times 1 is going to be 6, and then this is negative. So let's multiply straight across. So we can do, or sorry, let's add this together. We have a positive x to the 4th over 6 times 4 is 24, or we can just use 4 factorial. And it's a positive, yep. Positive 5x to the 4th over 4 factorial, and that is the answer. That is the first 4 terms, or sorry, first 3 terms, and this can continue on, right? So what we would have done, we would have multiplied this 2 into this x to the 4 factorial. We would have got x to the 6, and then 4 factorial times 2 factorial, and did the same scratch work, and then got that next term. So yes, that is question number 9, and I'm going to review the other couple questions that I already did, compile a video, and then this would be on my YouTube channel for the world to see that once upon a time I was in school doing Cal 2. And thank you, Professor. I hope that this clears up the problem. I hope this makes sense. And then yeah, the other 2 videos will be after this. All right, so for this next one, I'm gonna do the first one from the final review. I've already done a lot of the work, so it's gonna be, one is to write it as a fraction. So this is number 1, review, and you didn't give us a starting number or a whole number, but it's gonna be 0.45, and then it's 45 continues. So what I found out is that you have to carry the 4 to 5. It's going to be so you need to get to the 10s to the 100s. That's going to be the first one. That's your initial 45. But what I noticed is going by 10s. So this is by 10s, but by what exactly? So then after, simple multiplication, you notice that this is evens, and then the answer I came up with is going to be 45 to n. So you put this in, it'll be 45, 10 to the 2 times 1, and as we get the first one, and the same thing times 2, you get 4, just 10,000, and then 6, it's going to be times 3. I'm holding out kind of crazy. And then you get 6, and then this, of course, continues as that continues. And yeah, the answer is, as n approaches infinity, it's going to be 45 over 10 to the 2n. And that is the answer for number 1. All right, so I'm currently doing number 10 on I'm not sure if I explained myself on the other ones, but I'm currently doing the first part of the finals, not the second part of all my questions. And so I have the antiderivative, I found the antiderivative from 0 to 1 cosine of x to the 3rd, or x cubed, dx. And I have the cheat sheet of the Maclaurin series. I didn't say that in for the other question, but the Maclaurin series for cosine is going to be 1 minus x squared over 2 factorial. Well, with this problem, I'm entering, instead of x, every time I see an x, I'm going to enter x to the 3rd. So I've already written this down, except for here, because you asked for the first 4 terms. So first 4 terms, I have them all filled in. So I'm gonna kill 2 birds with 1 stone and just do this, add a 6, do this, add a 12, and then do this and add a 18. All right, so now I'm going to find the antiderivative starting with 1. So antiderivative is going to be x. I'm going to speed this up. And then it's going to be a 7. So 1 over 7 to the, I'm trying to see it, 1 to the 7. You have a 7, then you have a 2 factorial. It's going to be a 14. And then plus, I said 12, so it's going to be 1 over 13. And then you have a x to the 13. And this is also going to be a, oh, this is going to be nasty, times the 24, the 6, 24 times 24. Oof. And then minus, this is gonna be real nasty. Okay. 18, so that's 19. X to the 1 over 19 to the, what's 6 factorial? That's 24, 24 times 5. Let me do the math, 1 second. All right, so we found the antiderivative of the Maclaurin series with cosine x cubed. And now we want to evaluate this from 0 to 1. So give me some parentheses. Make it big enough so the camera can see. All right, so if I plug in 0 here, minus, this turns into 0, this turns to 0, this turns to 0. So that's all goes to 0, which is a good thing. Well, 1, so it would be 1 minus 1 over 1 over 14 plus 1 over 312 minus 1 over 720. So I'm gonna input that and then I'll give the answer. Some number less than 1, which is 0.9303, dot, dot, dot. It continues with some different numbers. I'll say I'm gonna round it actually, 4. And that is the final answer. Yep, that's it. Those are the 3 problems. I'm not sure what order I'm gonna put them in. But thank you so much for watching. For everybody who's a Bitcoiner, I will come out with more Bitcoin videos after my finals. It's the holidays, but if I don't, no promises. Happy holidays to you. I'll really try to make up more videos, but thank you, Professor, for a great semester. And hopefully I can do good on this exam as well as the finals so I can pass, so I can continue on this journey. But with life, I'll just retake it again if I do fail. So thank you so much, and I'm gonna get some sleep. Hopefully I got them all right. Hopefully there's 3 questions. Yeah, y'all have a good one. Until the next one, peace.